I love the many tastes of water.
Yeah, you've got northern.
Yeah, southern.
That's about it, but I really like them.
Mm.
Yeah, they're really nice.
Would you like to have a quiz about water?
I do love quizzes.
It's only one question, but it's quite good.
Okay.
What is the concentration of water in water?
No.
Hmm?
No. It's not a question. No.
It's not a question.
Mm.
It's in the book.
No, don't like chemistry. It's rubbish.
Chemistry is not rubbish. That is not a clever message. Wayne is an actor.
You thought I hated chemistry, didn't you?
Acting.
I've assorted the whiteboard. I mean, not this one before the camera was on. Yeah. And I've realised the concentration of water in water. I can answer the question, so don't worry.
It's okay. Let's think about water for a bit.
Let's think about it. So, you've got water. You know that. What it actually does is it sets up a reversible reaction forming protons and OH minus. Now you probably knew that water can break down into these things, perhaps not knew it was reversible, but of course it is.
Yeah, this is in many reactions and it happens a lot and both ways. You also know another thing, don't we?
Yeah, we do. The position of equilibrium of this reaction.
That is very far in this direction.
Millions and millions and millions of miles plus a couple of metres to the left.
If that's how you did it.
Yeah. So it's really far this way. So in my glass of water, almost entirely it's water, normal water.
Mm-hmm.
But part of it does dissociate into these two things, a little bit.
Little bit.
Very little bit. Yeah. So, because it's an equilibrium reaction, we can bring in our Kc, our equilibrium constant. We did a few videos ago how to do this, but I'll just have a quick reminder.
Yeah.
It's the products of the reactions as concentrations. So it's H plus, this is concentrations, that's what the square bracket represents.
And OH minus over our H2O.
And that's
As we
lovely.
to guess all concentrations. So that's nice.
That is lovely. We can do that. That was a previous video. So why is this a new video? Well, we're going to leave you in the dust. Hopefully you'll follow.
That's so to prevent really leave you in the dust.
Yeah.
It's just slightly damp dust, like mud, but
Yeah, just like that.
with less worms.
Hopefully.
So yeah, hopefully. So we can rearrange this a little bit, can't we?
We can.
Let's do that.
Okay, so we can take the H2O over this side and times that side. So we can say Kc times H2O, the concentration of water, equals the product of the concentration of the H plus and the OH minus. Now this will become more useful in a minute,
It will.
these two things, but we can rearrange it like this.
Now if we keep in mind that the concentration of H2O itself is constant.
Yeah. We can also say that the concentration of this and the concentration of this that is produced in neutral water is going to be the same.
Mm-hmm.
So it's going to be neutral. The amount of this is going to equal the amount of this for neutral water.
Which is pretty handy. A lot like our H squared we had.
Yeah,
over the
just like that. We could say H plus squared instead of H plus OH minus. That's only for neutral water.
Yeah.
So still write it like this. But we know that normal neutral water has a pH of 7. I'm saying this lots of time. I'm saying lots of weird things and repeating it, but it's going to be clear why in a minute. So it's got a pH of 7, our normal neutral water.
Normal neutral water.
Normal neutral water. It's got a pH of 7. And again, we've done a pH equation in a previous video, so we can work out the concentration of H plus by doing 10 to the minus pH.
Yeah.
So 7. And that, I think that just gives us 10 to the minus 7, doesn't it? I think. Yeah. That's what it's leave it there. It is just that. So that is our concentration of H plus.
Mm-hmm.
We can also say that OH minus is the same, so that equals...
It must also equal H, 10 to the minus 7.
Yeah, so they both equal this. So that's an important factor. Now this is the part where new things happen.
New things. So when is normal water normal water?
Well, when it's normal. That's a good time.
That's a good time. I think it's my favourite time of the week.
It is indeed.
Tangent being my least favourite.
Yeah. But we've got something called the ionisation product of water? Something like that.
Yeah. That's when we combine two constants to make another one. This is something chemistry loves doing. That's why we have so many constants.
It is. So you mentioned this is constant in a particular scenario.
I did.
This constant is probably constant.
Probably constant. I mean, it's one of the constants that changes, but
in a particular scenario, it's constant.
At a certain temperature. Let's say 25 degrees.
Yeah, so that's important.
That's a normal one. it's constant. So if you times a constant by a constant, you get a constant, and that's the one way I was going about.
It is, so Kc times H2O
Yeah, that bit there,
is our new constant, Kw.
which is very nice.
But because that equals that, what else could we say?
We could say that our Kw will also equal this. Or
They're both identical.
yes.
Now we can also say, for normal neutral water,
Right.
because these both equal the same thing, this is the same as 10 to the minus 7 times 10 to the minus 7.
Which is 10 to the minus 14.
So we can say that for normal neutral water, this Kw value is 10 to the minus 14 at 25 degrees Celsius.
Now, that sounded like a lot of garble. Maybe because it was.
It is a load of rubbish, but it's important rubbish for your exam.
It is more useful in buffer solutions when you can sort of work out things because you know that this is a fact. Only with pure water, of course.
Yeah, I'm going to say it again. Normal neutral water at 25 degrees Celsius, this is true. Kw, this constant,
Yeah.
is 10 to the minus 14. And you don't deal with any other temperatures in terms of
No.
knowing values, except from 25 degrees Celsius.
Although you do have to appreciate what happens at different temperatures.
So that's when it's not normal neutral water at
Yeah.
25 degrees Celsius.
So, hot neutral water,
Yeah.
still neutral, but it will have a lower pH.
As you increase its temperature to body temperature, 37 degrees Celsius, the pH has changed, as Trip just said, 37 does not equal. At 37, the pH changes to about 6.68.
Yeah,
Like that.
something like that.
So because the pH has changed, these values change, so the Kw changes.
But they're still equal.
Yes, so neutral, I kept saying neutral, that means that these are equal, as Trip just said, those two things are equal. So even though the pH is lowered, you might think that there's more of this H plus than there is OH minus, because that would make it acidic, right? Wrong. It means that it's still neutral at this pH.
Which is a bit confusing. And if you go the other way, it becomes more alkaline.
Yeah. So that's all of this in a nutshell. Oh, we only deal with 25 degrees Celsius for normal neutral water.
Yeah.
Hopefully it's in your brain by now, because I'm so tired of saying it.
What is quite handy is the pH of everything. The concentration of H plus and OH minus ions will always equal, when put together, 10 to the minus 14.
And that's always useful.
Yeah, any solution.
Yeah. So when you buy water from a shop, so you get Evian or whatever it is.
Yeah, Evian or, Buxton water.
They are alkaline. Their pH is about 8.
Yeah,
but
so
they're not neutral. There isn't equal numbers of these.
Yeah.
But you might be able to work, or you might know one of them, and using the fact that Triv just said equals 10 to the minus 14, and you know one of them, you can work out the other.
You can, which is pretty handy.
So next time you buy a bottle of water from a shop, just remember, you can do this if you were really sad.
Or just really interested, you don't have to be sad.
Well,
Well, you do.
You do really.